In example 2, we're going to continue our hypothesis testing for a population proportion. So in example 2, in a previous poll, 37% of families said they ate dinner together 7 nights a week. Recently, 371 out of 1070 families reported that they ate dinner together 7 nights a week. Is there sufficient evidence that the proportion of families who eat together has decreased? Use alpha equals 0.01, level of significance. Okay. So we're going to follow what we did in the previous example. There are 3 steps to conduct a hypothesis test for a population proportion. Okay. So step 1, we're going to set up the null hypothesis and our hypothesis, the alternative hypothesis. Okay. And once again, when it comes to setting up both, we need to identify the parameter that's used in the problem. Okay. Parameter, once again, will either be proportion, mean, or standard deviation for the population. Okay. So here, notice that we're saying in a previous poll, 37% of families. So this percentage right here is going to be a proportion. Okay, so proportion is the parameter of interest. So we'll denote that for both hypotheses. From the previous video, your null hypothesis in this class will always be set up as equal to. And for the alternative, we have to go in and identify which symbol to use. Are we going to use not equal to, less than, or greater than? And if you notice in the problem here, we're saying, is there sufficient evidence that the proportion of families who eat together has decreased? Okay, so notice they're using the word decreased. That's a key word for us to use less than. Okay, and then the value of the population, P naught. Here we're looking for a population value. Notice that 371 out of 1070 families, this is sample statistics. Okay, this is sampling data right here. 37% of families ate together 7 nights a week. So here, this is a population value. Okay, and that's how we set up the null and alternative. So notice what this says, similar to the previous video. The null hypothesis, we believe this is outdated. Okay, that the proportion of families who eat together is equal to 37%. A researcher came in and believes that that percentage or proportion has decreased. Okay, so we're going to see if we have enough evidence to back up that claim. So step 2, gather evidence. Okay, so to gather evidence, the setup in this class is to find the p-value, and that's going to be 1 prop z test. And notice how prop, that's proportion, we're using that when it comes to the parameter here. Okay, if you're using the parameter proportion in your setup for step 1, 1 prop z test will be the one of interest. Okay, and once we find the p-value with 1 prop z test, we will compare p-value to alpha. We'll compare the p-value to alpha. Okay, so in the calculator, let's take a look. So we'll go to stat, test, look for the 1 prop z tests. Okay, and we'll fill in the values that we're asked for. So p naught, once again, that's the population value. So here we're using 37%. So we'll change this to 0.37. And now we're asked for sample statistics. Okay, this is where the 371 out of 1070 families comes in. Here we took a sampling of 1070 with 371 being of interest. 371 ate together 7 nights a week. And let's plug in the sample size. And once again, this line right here in the calculator, we're looking to identify the alternative hypothesis, the alternative symbol. So we're going to take this symbol right here, and we're just going to translate it over here. Okay, so match this symbol with the one you see over here. this symbol right here is the one that matches exactly to this one right here. Okay, so we're going to change the not equal, we're going to put it right here to the less than. Now we calculate and we're going to see if we have enough evidence to back up our claim. Okay. Once again, there are three ways to gather evidence. We're showing the more practical way called the p-value method. In a separate video, I'll show you the other two methods, which are more difficult. You don't have to use them, you just have to use one method. So it's still important to note though, that MyMathLab will ask for a test statistic. And for now, I do want you to go ahead and enter the value that's presented in the calculator. We're going to type it in as is, negative 1.5, let's call that 1.58. If MyMathLab asks for 2 decimal places, 3 decimal places, we'll proceed however they ask. But go ahead and enter the value of the test statistic. I'll show you how to use this later. But again, the one of interest for us is p-value. And we're going to compare that to the alpha. So the alpha level is 0.01. That means we're given a 1% chance of making a mistake in our conclusion. After conducting our test, our p-value is saying you have about a 0.057 chance of making a mistake in the conclusion. Okay? So if we're given 1% chance of making a mistake, our test is telling us we have about a 5 or 6% chance of making a mistake. That's not good, okay, because we're above the threshold. And if we're above the threshold, that's considered weak evidence. And if we have weak evidence that backs up our claim, it's not enough. So here, we cannot reject the old data. We do not reject the null hypothesis. Do not reject the null hypothesis, okay? With weak evidence, we're not able to support our claim. With weak evidence, do not reject the null. So that brings us to our conclusion, step 3. Okay. So here we're going to begin by stating, do not reject the old claim at alpha equals to 0.01. There is not enough evidence to conclude that here we have in the problem the proportion of families has decreased, that the proportion of families who dine together has decreased. Okay, and once again from before, this is a typical format of how we state the conclusion in a hypothesis test. So we state whether we reject or do not reject. Once again, we had weak evidence against the null hypothesis. And if you have weak evidence against the null hypothesis, you cannot reject it. Okay, we got to keep it. State the alpha level, and then state whether or not you had enough evidence. So here we had not enough evidence. And then finally, we restate the alternative hypothesis. The decrease was the alternative hypothesis, so we restated it at the end.